Today I am here to explain an end-to-end architecture on creating a data pipeline. In this, there are a lot of components that are involved in this workflow or life cycle. So I would like to start the architecture explaining from left to right. So the first component would be your Terraform. Terraform is basically an infrastructure as a code. So you write the code, and that particular code, when you start running it, it eventually transforms into infrastructure. So we would going forward, we would see how we would write Terraform code and convert that particular Terraform code to create an Azure Blob Storage account and then storage containers. And then we will access this storage containers and blob storage using Python. So this can be done in multiple ways. So you can write Python routines which will run as a schedulers, crons, and then it will access some of the sources and then directly push that into the storage container, the raw data in fact that will be pushed into the storage containers. In fact, the source could be a local storage or it could be some third party system. So in case of if it is a third party system, we can expose our Python as a fast API, and then the third party system can access that APIs to upload the file, and in fact we will put that into the storage containers. Or a third way is the third party applications can directly access the storage container via the secure access tokens, which is called SAS, which is a feature inside this Azure storage. So those generating a different secure access tokens for every tenant or a client, then they would be sending the data with respect to the scenarios that they generate. And these are the three different procedures that we can actually push the data into the storage container. Ideally, these storage containers we can directly access by the Databricks, and moreover Azure hosts the Databricks cluster, and from the Databricks we can access the data, and then you can run your any kind of processing, could be Spark SQL or Spark ML, and then finally integrate with the ML flow to manage the machine learning workflow, and then push the ultimate model into the persistent storage. Or else we can take an alternate path where you can write your own Spark cluster. You can create your own Spark cluster, and that particular Spark cluster can contact the storage container, and the storage from the storage container it can read the data and then do the processing with respect to your requirement. Could be SQL processing or machine learning algorithm or classification regression kind of things, and then integrate to the ML flow, which is nothing but an ops, ML flow ops, and then you can even dockerize and put it into a Kubernetes cluster and then monitor this particular cluster. And ultimately from the ML flow you can expose the model, which we call it as model serving, and then we expose it via the fast API, which is nothing but the REST style of API endpoints, and then the client apps can access the REST endpoints for model consumption. And ultimately this model can again be stored into the model persistence, which is and this persistence can be again of two types, like on-prem or cloud. So Azure managed database services or AWS managed database services, or it could be an on-prem database. So this is an end-to-end data pipeline where you have ingestion phase as well as processing phase. Out of the whole architecture, we would be seeing this small part where we will be creating a Terraform infrastructure as a code, and then transform that infrastructure as a code into a real infrastructure. We will try to ingest the data, and then we'll create some Spark routine or Spark jobs to access the containers, and then create some kind of a classification or regression problem. So this is what we are going to see in next coming days, guys. Look forward for the channel. Please like, share, subscribe if you like the content. Thank you.